Corporate finance practice problem using OneNote. We're going to do a future value calculation, this time doing a comparison of compounding annually versus semi-annually. Don't leave generating profits solely to chance. Instead, use corporate finance. Here we are in our practice problem in OneNote. If you would like to follow along, you're not required to, but if you have access to OneNote and would like to, we're going to be in the item up top. I'm going to open up this item up top. We're in the practice problems section. We're down here in the 915. That's the 915 future value compounded annually versus semi-annually. I'm going to close this icon up to the left so that we then have room to work. We're going to have our information up top. We're going to be working multiple different practice problems. The first one is one that we've seen before, or similar type of problem. So I'll go through it a little bit more quickly. And then the last bit will be the new item where we're going to be comparing it to semi-annually, and that will be the new thing as we go. So if you want to jump forward to the new thing, then you can go to the end. We're going to start and go through the normal kind of process we've seen in the past related to the future value. We're going to have our information up top. We will calculate this 3 different ways. 1 with the use of the formula, 2 with Excel, 3 with the tables. So we got the invest 15,000 years, 11 years. The percent is going to be 10%. So we're imagining we're investing now, 15,000 now. What is it going to be in terms of future value terms after the period of 11 years? This time we are compounding annually like we have seen in the past using the 10% item. Once again, of course, the 10% is something that we would have to determine what that rate should be, and that's going to be some part of the estimate. We don't know what the rate should be because, we're estimating into the future as best we can. So formula-wise, it's going to be the future value equals the present value times 1 plus r to the n. And we're going to break that formula down into like a table type of format as we've seen in the past. Really think this is good practice to do. Oftentimes can help putting together tables. Recommend doing this in Excel. We do have this problem in Excel as well. So we'll take then the present value, that being of course the 15,000. Then we're going to be taking this piece, which is going to be the 1 plus r to the n. 1 plus r to the n, it's going to be 1, and then the rate's going to be the 10%. That's going to give us 110%. Taking that to the n, which is the number of periods, this being in years in our case, which will be 11. That's one of the things we need to keep in mind if it differentiates, if we're compounding, say, semi-annually or something like that. So let's go ahead and then do the calculation. We got 1. Then we're going to add the 10%, 0.1. That's, of course, 110%, 1.1. And then we're going to take that to the power of, that's going to be the little caret up top, 11 periods, 11 years. That gives us our, if I move the decimal place over, 28531 about. Notice this number is rounded here. And then if I take the trusty calculator here and we multiply that out, taking this times the 15,000, that's going to give us our 42,796. 75 about. Note again, it's rounded. So there we have that calculation for the future value. That's what we would expect in the future value after the 11 years compounded annually 10% rate. Let's think of it in terms of calculating it in like year by year type of calculation. This is really useful if you have Excel. It's easy to do in Excel. I recommend using Excel to do it, because it's good practice. So if we then have, and it also gives you a better idea of course, what is happening here. And so we got the 15,000 where we start in period 1, which is year 1. And then if we add 15,000 to it, which of course would simply be, the 15,000 is, pulling out the trusty calculator, the 15,000 times the 10%, 0.1 for a year. So a year's worth of interest would be that 1,500. Adding that then to the prior period amount, 15,000, that gives us this 16,500. If we then go on down and we do the same process on down, taking that 16,500 times the 0.1, that's going to give us the 1650. If I add that then to the prior balance of the 16,500, we're going to get then the 18,150, and so on and so forth. If you do this calculation in Excel, once again, easy to do, you can see exactly, what is happening with the compounding. You can see the interest going up as we go, as we compound per period, in this case, on an annual basis. So there's that calculation. We can see it in a similar format here. This would be more of an Excel type of exercise to kind of calculate it or format your table in a little bit different format of a way. So then we're going to go back down, and now we have in Excel, if we do the same calculation in Excel, we can use our little formula calculation here, which would basically be that we're going to be taking the, I believe it starts with the rate, and then we're going to say comma, and then we're going to be picking up the number of periods, which I believe is 11 here, and then 0. That's because it's not an annuity. And then we're going to have the present value, which is the 15,000. I believe that's how that's going to pull forward. We will work this in Excel. Highly recommend putting this into Excel. That would, of course, give us the quick calculation 42,796.75, which is what we got up here as well. But note that it doesn't give you really, the detail that it would if you saw kind of like the compounding that you can do a running balance in with Excel. But that's going to be the most common type of calculation you'll probably see in practice. People will just put it into a formula in Excel or a financial calculator. Magically, then the answer appears, and most people don't really understand anything more than that, right? But if you then have the tables, we've got the 15,000, then we pick up the amount from the tables, which is going to be the percent and the number of years. So here's the percentage, number of periods. We have to make sure to line up the periods and the percents that are going to be proper, this being years and rates. So that's going to be the 2.5804. So that's going to be the 2.85. Let's do that again. This was 10% and 11 years. 10%, 11 years. 2.8531. 2.8531, once again, giving us the 42,769,796.50. 42,796.50. So another method to get to the similar calculation. Let's do it again this time. We're going to do another one in years. We're not doing semi-annually yet. Another one in years. 15,019 years, percent, 10%. Let's put in this calculation. Future value equals present value times 1 plus r to the n. Doing that with a formula. 15,000, that's going to be the amount that we invest. Then we're going to take the 1 plus the rate, 10%. Gives us 110% to the power of n, which is 19 this time. That's going to give us then our 611.59. If we take that amount and multiply it times the 15,000 present value, we get the 91,738.64. If we saw that with the use of a period by period type of calculation, looking something like this, once again using years, period 0, we're at the 15,000. 15,000 times 10% would be 1,500, plus the 15,000 brings us to 16,005. 16,005 times 10% would be 1,650. 1,650 plus the 16,500 gives us the 18,150. 18,150 then times the 10% gives us the 1,815. 1,815 plus the 18,150 gives us the 19,965. 19,965 times 10% gives us the 1996.5. 1996.5 plus the 19,965 gives us the 21,961.50, and so on and so forth, bringing us down to the total at the bottom, which would be the 76,738.64 for the total interest, and the total balance 91,738.64. So we got the 91,738.64 that we have here. Similar way to do the calculation. This looks like a very long, tedious way, and it would be, of course, by hand. But with Excel, very easy to do this calculation. Gives you a much better understanding of how the interest is accumulating when you see it in that format. We could then, again, do it in Excel, which means we would be taking this formula in Excel. I won't break it out again with the Excel formula. We've seen it a few times this time, but that would give us the balance in a much quicker way as well. Same way with the financial calculator. If we do this in the tables, then we would take the 19 periods, because it's 19 years, the periods being in years, and 10%. So we take the 19 down here, and the 10%, which is going to be the 6.1159. So 6.1159 gives us the 91,738.50 once again. Tying that out, that's going to be the 91,738.64. 91,738.50, a little bit different due to rounding. Same scenario we have seen in the past there. Let's do this again. We're going to do it again. This not compounding still one more time on the present value in years. So we're going to say the calculation here. This is going to be 15,000 at 18 years, 10%. So 15,000 present value. Then we're going to take 1 plus the rate 10%, 110%. That's going to give us then to the power of 18, which is going to give us the 555.99. If I take the 15,000 times that amount, we're going to get the 83,398.76. So then we can do this with the calculation, year by year calculation here. 15,000 times, once again, the 10%, 1,500 gives us the 16,500. 16,500 times 10%, 1,650. 1,650 plus the 16,500 gives us the 18,150, and so on and so forth. Doing that on out till we get to the 18 years gives us an ending balance of the 83,398.76. That then matching the 83,398.76 we have with the formula calculation over here. If we do that then with a formula, similar kind of calculation with the formula, rate, which would be, in this case, the 10%, number of periods, which is going to be 18, because we're doing this in years, payment, 0 or two commas, present value, 15,000, same calculation down here. Then we're going to do the tables. On the table side of things, we'll then take 18 periods, because we're in years, and 10% per year. So we're going to take our good old 18 periods down here, and the 10, which is going to be the 5.5599, 5.5599. That then, multiplying that out, gives us the 83,398.50. Going back up, that's going to give us the 83,398.76. There is rounding for the tables. They are rounded to 4 decimal places, therefore not quite as exact. Good for practice, but slightly different. So then we have down here, now we're going to do the new thing. We have compounded semi-annually. So what is that going to do to our system? We are going to invest the 15,000 9 years and then 10%, but this time it's compounded semi-annually. So we have the present value, or the future value calculation, present value times 1 plus r to the n. But now we got a little bit of an altercation, because when we're thinking about the periods here, we're thinking about semi-annual as opposed to annual. So we got the present value, 15,000, and we got our 1 plus rate to the n. So we're going to take our 5%. Why 5%? Because we need to match the percentage amount up to the periods that will be covered. And now the periods are no longer in years, not 9 years, but it's going to be 18 periods, 9 times 2 periods, and the rate is often given per year, and we have to match the rate to the period. So the rate is given per year, because if you break the rate down to a per month rate, you're going to get to a very small rate. If you deal with yearly rates, then you have rates that are easier to report. It's hard to deal with if you're going to give a rate for a daily rate. It'd be 0.001, something like that. So those are harder numbers to just talk about. So we typically deal with rates in the standard format of years, and then have to match them from there to what's going to line up to the period. In this case, semi-annually, 10% then divided by 2 to get to the semi-annually. And that's going to be the 5%. And so if we take the 1 plus the 105, and then we take it to the power of 18, once again, 18 being different here. We're not taking 9, because 9 is the number of years, but it's compounded semi-annually. Therefore, we have 18 periods that we're going to be considering, and the 18 periods lines up not to the annual interest rate, but rather to the interest rate for the periods being covered semi-annually, 6-month interest rates. If it was something other than semi-annual, then you could break it out by basically dividing by 12, right? It would be a monthly rate or something like that. If it was quarterly, you divide by 12 and then multiply times 3, because there's going to be, or divide by 12 and then multiply times 3, because 3 months in a quarter, you can divide by 4 or something like that. In any case, then the calculation will be the same once we have these 2 items lined up. So we get the 240.66, and if we take the 15,000 times that 240.66, and this is in a percentage format, that's going to give us the 36,099.26, or the 36,099.29. Now, it's useful to run these in Excel so you can kind of see the difference of compounding annually and semi-annually a little bit easier. You can do that in here as well by basically comparing it to what we have done up top. So I'll just go back to the last one we did up top, where we had the 15,000 18 years. So we had 18 periods still here, but this was 18 years instead of semi-annual for 9 years, and the percent which was 10%, and we got to the 83,398.50 here. Now, if you consider here, we're talking about half the time period, 9 years at 10%, but we're doing the compounded on the semi-annually. So you might run some different scenarios to get an idea of what the compounding semi-annually would do. And again, I would recommend doing that in Excel and doing this type of calculation, but you also might want to do the running balance calculation down here in Excel, because that really gives you a better picture of what's going on from period to period. So let's try to do that running balance. We're going to say, all right, if we start off with the 15,000, we're now going to say the period 1 is 750. Period 1 is 750 because period 1 is no longer a year, but it's a semi-year. It's half a year, every half a year. So that means we're going to take this $15,000 amount times not the 10%, but times the 0.05%, 5%, 0.05 or 5%. Get the 750. The 750 plus the 15,000 is going to give us the 15,750. And then if we take that 15,750, I'm just going to delete this whole thing. If I take that 15,750 and I multiply it times 0.05, then we're going to get the 78750. If I take that 78750 and add it to the prior balance of 15,750, we're going to get the 16,537.50. If I take that amount and multiply it times the 0.05, then we're going to get the 826.88, and so on and so forth. Same kind of process, but we're going out to 19 periods. These periods, however, not being years, rather being semi-years, every 6 months, and then we get to the 36,099.29. So if you compare this kind of amortization table, or not this kind of table, to a table that for compounding annually or monthly or something like that, then it gives you a better feel of what the different compoundings will do. We can see the end result here, the 36,099.26 and the 36,099.29, 36,099.29. Okay, so then if we do this with a formula in Excel, we have a slight change here as well. We're going to take the rate, which is going to be that 10% we can pick up with a formula, which would be in this case in cell B3. So it would be in cell B3, the 10%, but we have to have that percentage line up to the number of periods, and the periods are compounding semi-annually. Therefore, I'm going to take that and divide it by 2. So we divide it by 2, that's going to give us our 5%, and then comma, number of periods. The number of periods now is going to be 9 years, but we're going to compound semi-annually. Therefore, I got to take that 9 years times 2, and that'll give us our 18. So now we got the 18 periods representing every 6 months, which needs to match the percentage not on a yearly basis, but monthly basis. Therefore, we take the yearly rate divided by 2, comma, and then we got the payments. There are no payments because this is not an annuity. And then comma, and we pick up the amount that was put in, present value, the 15. That once again will give us our same amount, the 36,099.29, 36,099.29. And then we have the table. Similar situation with the tables. You got to be careful with the periods that we have. So we got the 15,000, and then we're going to pick the amount up from the table. It's going to be 9 years, but we're not looking 9 years because we're looking periods, which is going to be compounded semi-annually. Therefore, it's going to be 18 periods. And then the rate is not 10%, but once again 5%, because the rate needs to be tied to the period that is being covered, which is semi-annual, therefore 5%. So we're looking 5% at 18 periods at 5% per period. So 18 periods down here, and then 5%, which is going to be the 2.4066, pulling the 2.4066, so 15,000 times the 2.4066 gives us the 36,099, which is close to what we have over here, 36,099.29, due to the fact that we have, once again, the rounding on the tables, it pulling out the percent off to 4 decimals. So that's going to be useful enough for practice. It's going to be a little bit different than what would be there if you used the calculations and didn't round. And note that book problems, test questions, might use that to try to force you to use one method versus another, so be careful about that.